Crash Course Instrumentation, Episode 42. How to measure current without blowing a fuse. Voltage is easy. Current? That's where things get tricky. In this episode of Crash Course Instrumentation, we're talking about how to measure current safely, correctly, and without blowing your meter's fuse. Or worse. We'll cover the basics of in-series measurement, using the correct jacks, and why non-contact methods like clamp meters are usually the better option when they're available. What is current? Current is the flow of electric charge, measured in ampere or milliamperes for smaller signals. You can think of it like water flowing through a pipe, but unlike voltage, which is measured across 2 points, current must be measured in line with the flow. That means breaking the circuit open and inserting the meter in series so the current flows through it. And that's where things can get risky. Step 1. Use non-contact current measurement when possible. Whenever you can, use a clamp-on meter or current transformer, CT. These devices measure magnetic fields around a conductor and calculate current without interrupting the circuit. Clamp meters are great for AC current and larger conductors. Some specialized meters can also detect DC current using Hall effect sensors. Current transformers are used in process and industrial systems, especially for monitoring higher currents continuously. These tools are faster, safer, and avoid introducing new faults by physically breaking the circuit. And in a live panel, that's a big deal. Step 2. If you must measure in series, do it right. Sometimes you have to measure low current in milliamp loops, especially with transmitters or control systems. In this case, follow these steps carefully. Turn off the power before inserting your meter in series. Never try to break into a live loop unless you're trained and using proper gear. 2. Move the red lead to the milliamp or amp jack, depending on the expected range. 3. Set your DMM to the appropriate current measurement setting. Manual range meters may require adjusting the range first. 4. Open the circuit and insert the meter in series so the current flows through the meter. 5. Restore power and watch the display. Suggestions for meter placement. If you're measuring total current, place the meter between the main power positive terminal and the wire you removed from it. If you're measuring individual load current, place the meter between that load's power wire and its termination point. Being methodical about placement can help you troubleshoot accurately and isolate faults. That's the fuse protecting you and your equipment. Don't use the amp jack for voltage. This is one of the most common and dangerous mistakes. If you leave the red lead in the amp jack and then try to measure voltage, you could create a short circuit across your meter, and that's a recipe for blown fuses, sparks, or injury. Always double-check your lead placement and selector dial before applying power. Fuse check and recovery tip. If your meter suddenly stops reading current, chances are you blew an internal fuse. Some meters have indicators, others don't. Always carry a spare fuse rated to the manufacturer's specs. Never substitute with random fuses or bypass them entirely. Your meter's fuse is part of your safety gear. Did you know? Early amateurs used moving coil mechanisms that physically deflected a needle based on magnetic field strength. These were rugged, analog, and only suitable for high current systems. The modern clamp meter, introduced in the mid-20th century, revolutionized current testing by making it safer and non-intrusive, especially in industrial settings. Quick recap. D. Current equals measured in series, not parallel. Use clamp meters or CTs when possible for safety. If measuring milliamps directly, turn off power. Insert the meter in series. Use proper range and jack. Choose correct placement based on whether you need total or individual current. Never leave the red lead in the amp jack when testing voltage. If the meter stops working, check your fuse. Thanks for watching episode 42 of Crash Course Instrumentation. In our next episode, we'll dive into resistance continuity measurement and why powering down is absolutely mandatory. Thanks as always to Tony Kuphaldt and the open source ModL community. Explore more at ebiblio.org, Kuphaldt, Socratic, Model, like, subscribe, and join our Facebook group to keep learning and stay safe in the field.